Hello and welcome to PatchMath, where today we are going to discuss compound interest. I'm doing this video because during the lesson, I started a new topic with number one. And if you take a moment and do number one in your own time, you will notice that for that problem, we were solving for R. And to be introduced to a new formula and starting at one of those variables that's surrounded by a bunch of other variables wasn't necessarily a good place to start this topic. So this video is a more of an intro to compound interest. I should have started with problem two. It is what I would consider intro to compound interest, in which we're actually solving for the final amount A in this problem. Now, for those of you who are not familiar with this formula, in addition to the final amount, we have our principal. That's a fancy way of saying the initial amount of money, what was there before time and rate compounded interest. Then we will put our rate right here in our formula. Notice that we will be using decimal form, and rates are traditionally given in percents. And then notice that n appears twice here. It has the same definition. We will be putting the number of times that our interest was compounded per year in both of those slots. In addition to our other variables here, we also have t, and that's just the number of years that we will be compounding over. In this case, going ahead and starting with number two, we see that our principal amount, that's our initial amount invested, is equal to $553. I'm going to go ahead and drop units for now, and I'll add those back in at the end. Moving on, we also want to make sure we define our R. In this case, R is equal to 9%. Let's go ahead and convert that. 9% is equal to 0.09. Moving on, we are also compounding annually. They are giving you a piece of information here, but they're not really being that forward about it. So compounded annually, we have to make sure that we are super aware of n's definition. N is equal to the number of times interest is compounded per year. So in this case, if it's compounding annually, n is equal to 1. So honestly, that's the best n. It makes our life so much easier in the math here. Moving on, we also want to know what t is, and t is equal to 2 years, so it's just 2. I highly recommend writing out your variables from the very beginning. Now, in this case, what I love is p, r, n, and t are all on the same side of the equation, and a is by itself. That is the easiest way to solve this. All right, so I went ahead and copied over the formula without all the extra definitions, just so it would be easy to see how all this correlated. What we are solving for what we are solving for here is A. That is our final amount. We're going to go ahead and substitute the P in there. Now, if you are one of my students, I always say, please put parentheses around whatever you substitute. In this case, that would just be a parentheses on the outside of a parentheses. It represents the same thing, and just so it won't look messy, I'm going to go ahead and drop that. So put them and then determine whether you need them or not. It can't hurt you either way to put parentheses around whatever you substitute. Going ahead and substituting in our rate in decimal form. Our n is 1. Now, I could just go ahead and write that as 0.09, but I'm going to go ahead and leave it for now, so that way you can see where each part came from. N is 1 again, and again, we can put parentheses around these things where they're positive. It's not really going to change anything at this time. And then this case, so that doesn't look like a 12, we do need parentheses here. So this is where I would be putting them, because 1 times 2 is a whole lot different than 12. In this case, this is just simplifying. If we're going to solve for A here, it's just simplifying the order of operations as they are given using PEMDAS. So that is parentheses. That's the order of operations. Parentheses come first, then exponents, then multiplication and division are created equally. Third, and parentheses, exponent, multiplication, division, and fourth is addition and subtraction, which are also created equally to each other. So in this case, the 555, or excuse me, the 553 stays as it is. We look on the inside of the parentheses. We have 1 plus this decimal. 0.09 is equal to 0.09. Excuse me, I don't know why I said it that way. 0.09 divided by 1 is equal to 0.09. Now, in this case, I'm going to go ahead and just leave my exponent as it is. It's better to follow order of operations to T's. Yeah, we have some flexibility there. Yeah, we could go ahead and multiply those out. You could. I'm not saying you can't. Let's just leave them. Let's go parentheses first simplifying. In this case, that simplifies out to 1 plus, wait, what am I writing? To 1.09. And now that parentheses is completely simplified, and we're looking at our exponent. Exponent 1 times 2 is 2. I'm going to go ahead and write it as such. Moving on, there's nothing more we can do on the inside of our parentheses. Our exponent is simplified, so now we can apply it. Why I keep writing 555, I don't know. That is 553. Pardon me. Um, in this case, you can type this into your calculator if you want to. 1.09 squared is equal to 1.1. And I'm going to go ahead and put the entire decimal here. Some of my students, their teachers allow them to round to different decimal place values. I respect whatever that is. So in this case, that squared has been applied, so we don't write it like I almost did. And we go ahead and multiply these two things. That is the last operation, so there is no order to choose from. The reason I go ahead and write that full decimal there is I am very aware that round off error gets magnified the earlier you round in a problem. And I want to make sure my students are aware of that as well. If you can round at the very end, wait till the very end round. Now, if you're given those never-ending non-repeating decimals, you don't really have a choice at a certain point. You can always hold the number in your calculator. It gives you a more precise answer. All right, so A in this case is equal to that number, but we do have to remember that this is a real world problem, and real world problems have real world parameters, and this is money. We're finding the final amount in the account after interest is earned over 2 years compounded annually. So that final amount is $657 and 2 cents because 1 followed by 9 rounds that 1 to a 2. In this case, we have completed number 2. And if your teacher is one of those teachers that wants you to have a sentence, and that's valid, I mean, it's going to hit you on standardized tests sooner or later. You might as well get used to it now. Is the balance after 2 years there is what I would put. All right. Well, there's your introduction to compound interest and finding the total amount compounded over a given time with a given rate. In the next video, we will move on to tackle a medium level problem in which we will be solving for a different variable. All right, well, look forward to working with you then. Thank you so much for your time.